Okay, this is going to be solving systems of equations by the substitution method. I do not have guided notes here, so please use a sheet of paper and write down the examples as I go. You can feel free to pause the video at any time to complete the example on your own once you get comfortable. But here we have a system. Okay, it looks chaotic. We need to apply order to our system. So first, I notice that one variable is isolated, the other equation is not. So I'm going to take my variable that is isolated, y equals -2, and I am just going to take the -2 right there. That is what y equals. When I have a variable isolated, you want to use the substitution method. I am going to rewrite the second equation, but instead of y, I am going to substitute what y equals, which is -2. Now I start to solve. Okay, line, combine, I've got -3 times -2, so I have 4x plus 6 equals 18. Move, I have to move everything away from my variable. I have 4x over here equals 12, and then isolate my variable, x equals 3. The solution that you're going to get with all systems of equation is going to be a coordinate point. Okay? Here, the x value is 3. Now, I need to solve for y. I need the y coordinate. Okay? When x equals 3, now luckily for us, y is already isolated up here. And since y is already isolated, I know that the y value is -2. So your answer is 3, -2. Now it looks a little bit different. Here I have y equals -3x plus 5. I'm still using the substitution method. I have 5x where I'm rewriting the second equation. Instead of 4, I substitute what y equals. Now I begin to solve. Line, combine slash distribute. So I have 5x. -4 times a -3 is positive 12x. Minus 20. -4 times a positive 5 is -20. So minus 20 equals -3. I have like terms. I am going to combine. I have 17x minus 20 equals -3. Now I have to move everything away from my variable, so I'm going to add 20 to each side. To move something over my line, I have to do the opposite. So instead of -20, I have to add 20. So these are gone from here. I have 17x equals 17. Now I need to isolate my variable. I divide by 17. My x value is 1. So when I write my answer, which is going to be a coordinate, a point, an x and y coordinate, I have x equals 1. Now I need to find y. I know what x equals. X equals 1. I need to find y. Here's where we use substitution again. You can pick any one of your original equations. I am going to pick the top one, and I am going to substitute my x value into the top equation. So I'm going to rewrite the top equation. Instead of x, I substitute 1 in for x, and now I solve. -3 times 1 is -3 plus 5. -3 plus 5 is 2. So my answer is going to be the point 1, 2. So I have y equal to x plus 3. I'm going to rewrite my top equation. Instead of y, I'm going to put x plus 3 because that is what y equals. Now I'm going to solve. Line, combine, or distribute. So I'm going to distribute 3x plus 9 equals 4. I have like terms. -3x plus 3x gives me 0x. So 0. These cancel out. They're additive inverses of each other, so they cancel out. So I'm left with 9 equals 4. Does 9 really equal 4? No, it does not. Okay? 9 does not equal 4, so the answer to this system is that there is no solution. Lastly, here, I have y equals x minus 1. I am going to substitute that into the top equation. I am going to distribute. So I have 3x minus 3x plus 3 equals 3. I'm going to combine my like terms. 3x minus 3x cancel their additive inverses of each other. So now I get 3 equals 3. Does 3 equal 3? Yes. So I get infinitely many solutions. So your solution set can be a coordinate point, you can have no solution, or infinitely many solutions. And that is solving systems by substitution.